Hi again. Recall in the previous video that player two's reaction function is a function of what player one is going to do, and I'm calling this equation one. And we were able to derive the isoprofit lines for player two, so the isoprofit curves, which are these red level curves that you see here on the graph. And we're basically using the profit function. Profit is, remember, um, it's price times output. So the inside part here, we use the inverse demand function to rewrite this as a function, as price being a function of output. And finally, we actually were able to solve the the reaction curve for player two, which I am calling equation three. And we did that by taking the partial derivative with respect to player two's output right here. And we set it equal to 0. Now we're going to talk about the leader's problem. So in this case, the leader being player one. Well, again, knowing that we have equation one, which is a function of what player one does, we're going to have a very similar maximization problem for player one. So P1 max, okay, this is going to be, we're going to maximize profit. Okay, so kind of econ 101 here. So this part is, this would be like, the revenue, and this right here would be the cost. But we're assuming that there's 0 cost, so we're going to write that off. And um, and since we defined in equation one, we defined y2 as a function of y1. So player uh, player two's output is a function of player one's output. We are going to we're going to write this inside part. So once we actually we're going to rewrite this inside part as okay. So we're maximizing player one's profit. And really here, because we're actually just dropping the cost, we're just assuming it to be 0. Instead of just doing like the normal maximization problem, first order conditions, all that, this is just going to be simply, we're just going to go ahead and just solve it for profit. And profit, so player one's profit is just going to simply be um, well, P of y1 plus y2 times y1. But remember, the y2 we've redefined as a function of y1 because that is because player two reacts to what player one does first. And of course, we're going to use the inverse demand function. So let me just go ahead and write it using that notation. All right, and so that I got from this, because remember up here, we are defining the inverse demand as a function of the two players' output. All right, so, and this is exactly what we did before for player 2, but there's one key difference you'll see here in a second. Okay, so this almost looks similar to what we did before up here, but now we're going to go ahead and plug in equation 1. We're going to go ahead and plug in equation 1 for y2. And we've actually defined that. Well, we actually solved for that and derived it by finding player 2's reaction function, which is equation 3. So we're going to go ahead and plug in equation 3. Okay. And this is actually going to equal, let's keep the same colors here. Now instead of y2, I'm going to plug in this right here. And we're just going to go ahead and simplify that. Let's see. Oops, this is supposed to be made a mistake. These are all supposed to be negatives. There. Whoops. Okay. So, sorry about that. Okay, so minus b. So a b y1 plus b y1 squared, and all of this over 2b. All right, we're gonna simplify that a little further, and that is going to equal 2ba y1 minus 2b squared. Oops. I kind of just wrote the same thing twice, but that's because I ran out of space. All right, so this is we're gonna go ahead. Remember, we want a common denominator, so I'm gonna let's see what I do here. Whoops. What did I do wrong? Oh, okay. Yeah, that is the common denominator, so actually, yeah, that's correct. Okay, so now that we have a common denominator, we can Let me just make sure my algebra is correct here. Yes, so now we can simplify terms. So let's see. That is y1. Okay, so I think we can simplify this and this. Okay, so that's going to be a, b, y1, and let's see, 2b squared y1. Okay, so then we can simplify these terms right here. That's just going to be b squared y1 squared all over 2b. We can factor out b. That's going to be b a y1 minus b y1 squared. 2b, b's cancel. And now we have a y1 over 2 minus b y1 squared. All right. And okay, so now let's see. I'm going to call this equation 4. All right, so now, okay. Now we're going to go ahead and set this equal to 0. And this is our marginal revenue equals marginal cost equals 0 condition. And let's see, this is going to imply and if we take the first partial derivative with respect to y1, then let's see, that looks something like this. Then we're going to be left with a over 2 minus b y1. Okay. And then solving for y1, this is going to imply that a over 2, a over 2b equals our solution for y1. So this is going to be player 1's output level. And actually, if you plug this into player 2's reaction function, which is equation 3,